In the global chess match for the future, a new, critical frontline has just been opened up. But it's not on some remote battlefield. It's inside a hyper-sterile cleanroom. We're talking about a secret, nationwide mission with one single goal: build the impossible. And in doing so, break a technological monopoly that our entire digital world depends on. This, right here, is the story of China's Silicon Manhattan project.
Well, I think when we talk about China's ability to have an advanced semiconductor sector, the question isn't, can China make fabs? Can they make equipment? The question has always been, will they have access to EUV lithography tools or be able to make their own? And the reporting that came out yesterday shows that China now has a working prototype of some type, which I think to a lot of people came as a surprise.
Just read that sentence again. When this report came out, it sent absolute shockwaves through the entire tech industry. For years, pretty much everyone thought this kind of technology was way beyond China's reach, that it was locked down tight by a fortress of patents and sanctions. But clearly, inside some secret facility, something huge was happening. Something that honestly changes everything. So how in the world did this happen? Well, to figure this out, we're gonna follow the trail like detectives. We'll start with the machine itself, the impossible machine. Then we'll dig into the wild science that makes it tick, meet the secret crew who actually built it, and then zoom out to see the massive national strategy that was driving this whole thing. And finally, we'll ask the big one: what does this mean for the rest of the world, and where does this race go from here? To really get how big a deal this is, you first have to understand the sheer scale of the monopoly that was just broken. For decades, one single company, the Dutch giant ASML, basically held the keys to the entire kingdom of advanced computing. They were the only company on Earth that could make the most complex, most expensive manufacturing tool ever created by human beings. And this is it: extreme ultraviolet lithography, or EUV. Think of it like a ridiculously advanced printing press. But instead of ink, it uses a very specific wavelength of light to carve microscopic circuits onto silicon wafers. Circuits that are thinner than a strand of your DNA. Look, controlling this tech means you control the future of, well, everything. From the most powerful AI data centers to the smartest military hardware. Without it, you simply cannot make the world's most advanced chips. Period. Alright, so that brings us to the first crucial question. If the world's best technology is completely blocked off by sanctions, how on earth did China manage to build its own version? Well, the answer is pretty fascinating. See, they didn't just steal the blueprints and copy them. No, they invented an entirely new kind of engine. And this is where things get really interesting, because the two approaches are fundamentally different. ASML uses a technique called LPP. It's super precise, using powerful US-made lasers to blast tiny drops of tin 50,000 times a second, turn them into plasma. China's method, LDP, is totally different. It uses a homegrown laser to vaporize the tin, and then hits it with a massive jolt of electricity. It's like if you were banned from buying a sleek, compact jet engine, so you decide to build a massive warehouse-sized rocket engine instead. It's a brute force approach for sure, but crucially, it gets around all those Western patents and sanctions. And this table really shows you the trade-offs. Just look at the numbers. China's machine, it's way less efficient. Its power output is a lot lower. And its size, an ASML machine is about as big as a school bus. The Shenzhen prototype, it takes up an entire factory floor. But here's the killer detail, the part that matters most: it works. And it's built almost completely with their own domestic technology, which means it's basically immune to any foreign sanctions. Now, a machine this complicated doesn't just build itself, which leads to our next big question: if all the tech is a closely guarded secret, who are the people with the know-how to actually build one? And this is where the story shifts from a science project into an espionage thriller. So how do you get that priceless knowledge? Turns out, you buy it. China launched this incredibly aggressive recruitment campaign, offering what can only be described as life-changing money. We're talking signing bonuses of up to $700,000 US on top of things like housing subsidies, all to lure away the one thing you can't just reverse engineer: decades of hands-on experience. And the level of secrecy here is straight out of a movie. Once these veteran engineers were on board, they became ghosts. They worked inside a sealed-off compound, they were given ID cards with fake names, and every single thing they did at their desks was recorded. One engineer was apparently stunned when his hiring package actually came with a pre-assigned alias. I mean, wow. This all reveals a really sophisticated two-part strategy. First, you go out and recruit the veterans, the experts who have that deep system-level knowledge you just can't get anywhere else. But then you combine that with a brute force approach. You create these shadow supply chains, secretly buying up older machine parts on second-hand markets. Then you give those parts to huge teams of fresh young graduates and just tell them, figure this out, rebuild it, piece by piece. So this brings us to the big picture. Why was this project so incredibly important? I mean, why go to all this trouble? Because this prototype wasn't just some company's R&D project. No, it was the crown jewel of a massive, state-directed national mission. It was, in effect, a Silicon Manhattan project. And the money behind this is just staggering. The Chinese government set up something called the Big Fund, and its latest phase has $49 billion in it. The whole point of this fund is to make cost a non-issue. It pays for the ridiculously high production costs and absorbs the initial bad yields. It allows them to put national security first and profits a very, very distant second. And they're not just throwing money at the problem. They're also forcing the entire domestic industry to level up. They've put in place this unofficial but very strict rule. Any new chip factory has to get at least half of its equipment from local Chinese suppliers. This creates a captive market. It means huge customers have no choice but to buy local, which forces those local suppliers to get better, faster. And who's at the center of this giant web, coordinating everything? Huawei. After being hit with sanctions that threatened its very existence, the company is basically transformed into the command and control center for this entire technological war effort. It's the hub that connects government labs, private companies, and thousands of engineers into one focused national mission. Okay, so we've looked at the how, the who, and the why. But that leads us to the biggest question of all. What does this breakthrough actually mean for the rest of us? Well, the consensus is pretty clear. This is the end of a single global tech market. A new divided world is emerging. A silicon curtain is falling. And you can see on this timeline just how quickly everything has escalated. It's a classic case of action and reaction. The US controls in 2018 and 2022 were meant to slow China down, but instead, they acted like a massive catalyst, lighting a fire under this project. Now the projections for when China will actually be producing its own advanced chips with this tech are as early as 2028. And here's a really clever part of this strategy. It's not just about the fancy high-end chips. While the world is obsessed with the race for AI, China is getting ready to dominate the market for older but still absolutely essential chips. You know, the workhorse chips that go into our cars, our refrigerators, our washing machines. By 2030, China could control over a third of this global market, creating a powerful new kind of dependency. Now this is where the consequences get truly serious. For decades, there's been this idea called the silicon shield. It's the theory that because the world, including China, depends so heavily on Taiwan for the most advanced chips, the island is basically too important to invade. But as China builds its own chip supply chain, that shield starts to get weaker. If Beijing no longer needs Taiwan for its most critical chips, the entire strategic balance in Asia could change. But let's be very clear. This is a huge game-changing development. But it is not the end of the story, not by a long shot. China has cleared one massive hurdle, for sure. But this is a marathon, and there is still a long, long way to go. A whole new set of massive challenges are standing between their prototype and true leadership. First up, power. Can they scale their machine from its current 150 watts up to the 600 watts needed for real mass production? That's a huge question. Second, it's not just the machine, it's the whole ecosystem of special chemicals and gases that are also under export controls. Third, and this is a big one, is yield. It's one thing to make a prototype work. It's another thing entirely to make millions of perfect chips with almost zero errors. And finally, the goalposts are already moving. The West is already rolling out the next generation of this tech, which means this whole brutal race is starting all over again. So what's the big takeaway from all this? The Western monopoly on this foundational technology is broken. The era of a single global tech ecosystem is over. We're now in a new world, one divided by a silicon curtain with two completely different competing tech stacks. And that leaves all of us with a huge lingering question. In this new fractured world, who is going to build the future?